E-mobility usually means many vehicle types, brands, and data protocols. If you clicked on this video, you might be managing a fleet like this. Good news, you can use one GPS tracker to monitor it all, Teltonika's FTC or FTM305. How? With manual CAN functionality. Manual CAN lets you access vehicle data via CAN bus by defining it yourself without additional CAN protocol development on the device firmware side. With manual CAN data and commands, FTC and FTM305 devices open up flexibility across a wide range of use cases. For example, if you are running an e-bike rental service, it allows you to monitor battery level and mileage in real time. If your client is using e-scooters for deliveries, battery performance and driver behavior play an important role. This is another type of data that FTC and FTM305 can provide. And we cannot forget about electric machinery and utility vehicles. With manual CAN, you can track operating hours and quickly spot inefficient usage patterns. But manual CAN is not just about reading the data. It also enables remote control, like locking or unlocking the vehicle, setting speed limits, or managing other systems. So the benefits are pretty clear. You can deploy faster without waiting for protocol implementation. You can get full flexibility for any vehicle or use case, and your know-how stays completely confidential. Now, let's see how to configure manual CAN on FTC305 using TCT. First of all, connect the tracker to your computer using USB Type-C. Open TCT. In Discover Devices section, select your device and click Configure. Then navigate to CAN or BD Settings section. First, configure General CAN settings. Select the appropriate baud rate based on your CAN protocol documentation or apply Auto to detect it automatically. In the CAN Features section, open Manual CAN. Here, you set up which CAN data will be read from the vehicle. CAN configuration should follow the communication protocol of your vehicle. In this video, we're using a sample protocol. To read specific data, for example, battery status, you need to define the CAN type and CAN ID based on your protocol. In this example, battery status message uses standard 11-bit CAN type and CAN ID 0x300. In TCT, set the CAN type to standard 11-bit and enter the CAN ID without the prefix, in this case 300, in order to select the battery status message and receive data such as battery level, current, temperature, and voltage. In total, up to 70 manual CAN messages can be configured for FTC or FTM305 devices. To send commands, such as lock or unlock, open Manual CAN Commands section. Refer to your CAN protocol documentation for command details. In this example, both lock and unlock commands use standard 11-bit CAN type, CAN ID 0x600. For the unlock action, the protocol specifies the value of 1 in byte 0 and data length of 8 bytes. In TCT, set the CAN type to standard 11-bit, enter CAN ID without the prefix 600, define the data field, and set the data length to 8 bytes. Unlock command is set up. For the lock action, the same CAN ID is used, but the value in byte 0 changes to 2. In the next command line, enter the corresponding command data. You can also define how the command is sent, once periodically or triggered by a specific CAN event. This is how manual CAN commands are configured based on your protocol. In total, up to 10 manual CAN commands can be configured for FTC or FTM305 devices. After configuration, you can verify both data and commands. For data, check your server, platform, or app and make sure the values are being received and updated correctly. For commands, trigger an action from your server or application. In our example, the first command is for unlocking and second command is for locking the vehicle. Confirm that the responses to CAN commands are reflected in the system. Thank you for watching, and we are looking forward to seeing you in our next videos.